All right, let's get started. This is chapter one of the Intro to GIS class using ArcGIS Pro for the first time. And this class starts from scratch, and with that, we have to start with some basic GIS data concepts. In a nutshell, we're trying to represent a real world thing, whether it be a place or a building or a natural phenomenon, on a flat screen, a two-dimensional map. So with that, you have to make some concessions. You have to understand the concepts that go into trying to map on a two-dimensional screen. So first thing we need to do is understand the different types of map data. Now these four types of map data are going to be used over and over and over and over again all semester long. So it's important that you start to wrap your head around how these concepts work. So what we want to do is we want to look at the real world and understand, okay, what's being represented here and how is it being represented? And some of that is determined by the scale, which we'll talk about in a bit. But in a nutshell, you have four kinds of data, three of which are called discrete data. They exist in a defined location or space. So for example, you have a lookout tower, which could be represented as a point. And here, let's say this green triangle and the figure down here is a lookout tower. We have a stream, which can be represented as a line. And again, here's a line. Hopefully you can understand that that's a stream, this blue line here, which I'm now making red. And then finally, a snail habitat, which is represented as a polygon, sort of a space where we might find a particular snail depending on the conditions that we gave it, which we won't get to till later in the semester. But that's what these sort of brown polygon looking things are, and they have what's called area. They have area to them, which is hugely important down the road. And then finally, we have what's called continuous data. Data that sort of always is changing a little bit, even just a little bit. And one of the easiest ones to understand is what's called, well, the data type is called a raster. And the easiest one to understand is elevation. So a raster is similar to a picture you might take with your phone, which is in what's called a JPEG format. It consists of cells, and each cell has one and only one value. In a JPEG off your phone, it represents a color variation. You put all those cells together, you get an image. Same thing applies here with a raster, except each cell is represented by one and only one elevation um, number, and that could be out to maybe a thousandth of a meter or a hundredth of a meter. And so each one is slightly different, creating a continuous surface. And we represent that just like we would with an image with a color scheme to sort of represent the highs and lows of elevation. So again, just to reiterate, we're going to deal with points, lines, and polygons throughout this course, along with various types of rasters, which is a grid system with each cell representing a different value. We'll get more into rasters later on. So there's two main types of GIS raster models, and I just sort of mentioned them in the previous slide. You have the vector model, which is best represented with discrete data. So things like state boundaries, which are lines or polygons, streams, which are lines, and then snail habitat, again, which is more polygons. So these are sort of the points, lines, and polygons, which is what's called a vector model. Now, if you've ever used anything like Adobe Illustrator or CorelDRAW, those are what are called vector graphic programs. So the program is using a very specific mathematical formula in the background to place the line or a circle or a square or whatever you're drawing exactly where you want it. The same thing applies in GIS, except it's bounded by the space in which you put it in. So if we put Wisconsin in the United States, we want it to be where Wisconsin actually is. And the program handles a lot of that for us. Sometimes you have to make adjustments, but a lot of the stuff's handled for you, and then you can utilize the data going further. The other model is the raster model, which I just mentioned in the previous slide again, which is a grid work of cells with values, and each value represents a small change in whatever phenomenon like elevation or precipitation. Um, It's used for imagery and best for continuous data. So each cell value is typically changing at least a little bit, either in elevation, precipitation, or in the case of aerial photography, which is similar to a picture you would take on your phone, it's going to change slightly in color value. So you have vector model, which is points, lines, and polygons, and the raster model, which is the grid system where each cell of that grid represents one and only one value of whatever phenomena you're trying to represent. For example, elevation, aerial photography, or let's say precipitation. So like I mentioned in the previous slide, the vector model is best for discrete data, and it's features stored as map objects. So points, lines, and polygons, like I mentioned before. Now here's where the jargon starts to come in. So features are points, lines, and polygons. Okay, so if I have one point, it is a feature. If I have one line, it's a feature, or one polygon, that's a feature. Now, a feature class is a collection of similar features stored together, like all of the states, which are all polygons, or all of the major rivers in the country, or let's say all the volcanoes, which might be represented as a point. So when you put those together in one cohesive unit, it's called a feature class. Okay, and this makes using GIS much easier because things are sort of collected together, and you can utilize the ones you need, or you could discard the ones you don't need. So the features are grouped together in what's called an attribute table. And this is where you start to get into sort of the database portion of uh, GIS. So the I, which is information. Features are linked to tables containing information about the spatial objects, and then therefore the table is connected to the map. So if I place a feature class on my map, I start to see all of the states in the country, as you can kind of see in the background here. Okay, so within that table is going to be all 50 states and the District of Columbia. So there's actually 51 in there. And you'll notice that each one of these has a unique identifier here. These are just, integers going from 1 to how many I ever have in my table. And you have so we have numbers of rows and we have columns. It's very similar when you first see it to an Excel spreadsheet, however, it acts much differently. Now you'll see this sort of light blue color on your screen. You're going to see that a lot over the course of the semester. And what that's telling you is that something's been selected. So if I highlight it on my screen, that same color is going to be highlighted in my table, or vice versa. If I highlight them in my table, it tells me which ones on my map are highlighted. So in this case, we have Washington, Oregon, and Idaho here's selected. And you can see that they're right here, Washington, Idaho, and Oregon. So these are the types of little things that you're going to have to start to get used to as you use GIS. That light blue color is very important. We'll discuss it quite a bit. In fact, there's a whole essentially 2 chapters on how to do different types of selections. It's a very important part of GIS, especially for whittling down data to just what you need for your particular analysis. Now, the raster model, like I mentioned, is a grid series where you have a specific number of rows and columns, and for each cell, you have one and only one unique value. Now, the way the program utilizes this rasters is it has to know the location via latitude and longitude of the upper left corner. From there, it'll tell you, it says how many columns it has and how many rows it has, and it also knows how big each cell is. Now, when I say how big each cell is, that's sort of the resolution of that particular raster. 10 years ago, the most common resolution was 30 meters. So each square was 30 meters by 30 meters. Nowadays, it's gotten down to 10 meters is the sort of standard. And with the advent of things like LiDAR and other types of data acquisition methods, you can get sub-meter resolution, very, very high resolution data. But for our purposes, what the program needs to know is what's the location of the upper left corner, how many columns, how many rows, and then it can determine exactly where on Earth to place that particular raster. So we call them cells in GIS land. You've probably heard of pixels. When I do website development type stuff, I do everything in pixels, so I know how big it's going to be on a standard size screen. So the thing that really makes rasters different from vectors is the fact that each cell value only gets one and only one value. Okay, so for every cell, there's one elevation value. For each cell, there's one precipitation value. We're going to go into this in great detail. There's a whole chapter on rasters, and it's sort of my bread and butter in terms of what I do outside of teaching. Raster work is a lot of fun, and it allows me to do all types of things like the wine vineyard suitability stuff I work on with Dr. Barry Cameron. So when you're dealing with GIS data, inevitably you're going to have to deal with map scale. And hopefully you've seen some of this before in previous courses. So I'm not going to dwell on it too much. But the idea is that map scale is the ratio of distance on the map to the distance on the ground. It's usually dimensionless and can be expressed in any units. So you can see from the formula in the image here, if you have a 2.5 centimeter long polygon in this case, you can quickly do the math to estimate that that's about 2.5 kilometers across. Okay, if you're at 1/100,000 scale on your map. Now the beauty of GIS is as opposed to let's say a static printed map, is you can change scales very quickly just by zooming in and out. Well, with that um, comes other issues in terms of dealing with data quality, which we'll get to in a minute, and making sure that the data you're using is designed for that particular scale. So that brings us to what's called generalization. Okay, generalization is used to simplify map features for clear display. Now, for a small scale map, and if you remember correctly, small scale means it maps a large area, and a large scale map represents a small mapped area. Um, you can have vastly different looking data on that particular map. Now, if you look at the image on the left here, this the purple line here was mapped at 1 to 25 million. Now, for a map of the entire United States at once, this is probably fine. The generalization is not a problem. However, if you're doing detailed scale work at looking at some sort of shoreline erosion factor, you're going to definitely want this 1 to 50,000, which is in the black here, this where you get all of the very good detail here, because you need to understand how the erosion is taking place. You don't want to generalize it because the different types of nooks and crannies could be affecting the rates of erosion, just using that as an example. So the source scale is the scale at which the data are captured. And that's really important, especially when you're downloading the data, let's say for your project later on this semester. You don't want to download data that was designed to be viewed from way far back. You want it to be viewed at a scale that you could use it at. Now, for projects in this course, I tend to not allow you to do large areas. So it'll be sort of a large scale map, maybe at the county level. So the detail will be there without, becoming too cumbersome. So like I mentioned earlier, GIS has the ability to quickly change scales just by zooming in or out. However, because of the data that the scale that the data was designed for might be vastly different than what you're looking at it in, it's hugely important to make sure you have the data for the correct map. So larger scales maps have finer sampling distance or resolution. So with that comes, let's say, higher file sizes. The more resolution you have, the file sizes get bigger. So especially in raster world, we'll get to that later. But you don't want to carry around more than you need to. If you download something that's for the entire United States when all you need is the shoreline here along the East Coast, it would be much better to go somewhere to find that data specifically to be able to further map it in a much finer resolution. So what happens if you don't get the correct data for the scale you're trying to work at? Well, the differences become very obvious very quickly. So you could see in the image on the left here, The blue, or excuse me, the purple line here, these represent some sort of boundary, and they're vastly different than what's on the map behind it. Why? Because the purple line has been um, mapped at a scale that's much more generalized to be viewed from further out, just to give a rough estimate of where those particular boundaries are, whereas the map in the background with the dashed lines is a much more detailed version of those same boundaries. So again, it goes back to making sure you get the data you need for the purpose you need it for and at the scale you need it at. So you can quickly estimate precision from scale. And for the purposes of this class or your final projects, this is not an issue. I don't grade on this or anything like that, but it's something to think about when you're mapping, especially at small scales, that a 1 point line, the thickness of your line can vastly overestimate or underestimate where you're actually your data is. So a large symbol creates lower precision depending on which scale you're looking at. So that's really all I want you to get at this slide, is that sometimes it's nice to use thicker lines for a visual aspect, but you're creating some uh, imprecision by doing so. Now, data quality is something that, when you're doing a GIS project, you always have to have in the back of your mind. So you can see from this set of this slide, data sets are rarely perfect. You're always gonna, especially in raster world, you'll end up with things like outliers or what are called sinks if you're doing hydro analysis. There's no standard that exists across all entities. Now, there's certain data sets that have more stringent uh, uh, definitions than others, but across the board, there's no one absolute standard. So you're kind of on your own depending on where you get the data. So soil data might be have its own set of rules as opposed to, let's say, precipitation data from NOAA. So the quality is defined as the fitness of a data set for the particular purpose, and that goes back to the map scale. If you're doing a citywide data set analysis, you should be getting your data sets from the city, not from the federal government, because those are going to be much more generalized because they're just looking at, let's say, countywide or even statewide or nationwide type boundaries. So you want to sort of drill down to get to the entities that have the highest resolution data for your purpose. If your purpose is just to make a pretty map of the entire United States, that's fine. Then go ahead and use the data that's appropriate for that. You don't need all that super high resolution, let's say along the East Coast, like we saw a couple slides ago, because you're not going to see it at that scale anyway. And then the bottom one, user has an ethical and legal responsibility to determine whether a data set is sufficient for its intended use. We'll talk about ethics, I hope, if we have time at the end of the semester. It is a big thing, and what you'll understand as you go through this course is GIS isn't that hard, and a lot of people know how to do this stuff, and you can quickly change things to, let's say, fit an agenda. No different than during a political cycle when you have graphs and charts and this and that. You always have to kind of look at it and go, okay, who's making that chart? What do they have to benefit by it? Those kinds of things. So you got to be very careful that when you're using data in GIS, that you're using it for the intended purpose and to not sort of fit the outcome to the data. Let that data dictate the outcome, whether it's right or wrong. You might not get the answer you want, but that's just sort of how it is. And it's that way with all science, but it is very, very prevalent in GIS because literally anybody can do this once you kind of learn a few things. So geometric accuracy is something that we're always striving to keep to a minimum, so to speak. How well is the data fitting the real life version of what we're trying to map? How closely does it mimic it? And a lot of that is dictated on how the data was collected. And in many cases, you don't have access to that, or you're not collecting the data yourself, you're downloading it from some other entity. So you can uh, you hope to have the best type of data that you can get, and sometimes it just doesn't always work out. One of the other things that that can happen is as you use a data set, if you're processing it in certain ways, you can actually propagate those errors even further. You can make them worse. And that's especially true in raster world or with projections, which we'll get to later in the semester as well. So you have to make sure ahead of time, looking through what's called the metadata, which we'll talk about eventually, looking through how it was collected, when it was collected, what's the resolution, the precision, which are not the same thing, and then assess it to can I is there a possible way to make the data better, or is the analysis I'm going to pursue going to make any errors that much worse? So these are things you kind of have to keep in mind, not so much for this course, admittedly, because the data you get is the data you're going to use. But in the real world, you definitely have to keep this stuff in mind, especially like if you're doing engineering or anything like that, where either money's involved or safety's involved. Like if you're digging up power lines and things like that, you don't want to hit gas lines. Think of like um, when you have to call if you're digger's hotline and stuff like that. That stuff has to be very accurate. Another consideration to take place is something called thematic accuracy. So how accurate are the attributes, the columns of data within the table itself? You'll never know this exactly, but you like to trust the sources you're getting the data from. If you're using census data from the federal government, you'd like to think it's correct. However, let's say, for example, using the tree crown density, that's a very generalized type of analysis. So how is it measured? How accurate are those measurements? What are the possible sources of error? These are things that you have to take into consideration when you're doing sort of research on your own, where you're taking a data set and you're going to process it further and then ask yourself, okay, is what I'm looking at true to what I'm trying to get at? For example, when I'm doing vineyard site suitability, I have a lot of inputs going into there, both raster and vector, and I have to make some choices. I'm using those choices based on previous research being done. um, and that's a big part of it is understanding the processes in real life. How are the grapes being grown? Where are they planted? How good is the raster that I'm using for slope? I want a higher accuracy, a lot of accuracy, because my vineyard doesn't take up a lot of space, so I don't want 30-meter DEM where that's like, half the vineyard right there. So you have to ask yourself these questions, making sure I'm using the right data. How accurate is it? If I run an analysis on it, is it going to be within the confidence limits that I'm comfortable with to, let's say, produce an output and, let's say, present that to, let's say, a research article? So these are the kinds of things you have to keep in mind as you go forward. So this brings us to resolution and precision, which are not the same thing. So let me go through this a little bit and try to get you to understand the difference. So resolution is the sampling interval of measurements during data collection. Now, me coming from the seismic world, I understand this all too well. So let me give you an example. In the vault down in the basement of Lapham Hall, we have an active seismometer. It's running 24/7. That seismometer allows me to sample at different rates. So I sample one type at 40 samples per second. So every second, it's taking 40 digital samples. And the other one is at one sample per second. So every second it takes one sample. Now there are various reasons to do this. A lot of it has to do with resolution. If I have a earthquake that is, let's say, semi close to us in this upper Midwest region, Illinois, Missouri, Indiana, that kind of area, the 40 sample per second will allow me to capture it with much more high resolution. So that's why I do the 40 samples per second. That's a higher resolution, right? The one sample per second, because the vast bulk majority of the earthquakes that we recorded in Milwaukee are very far away. And I say very far away, anything more than, let's say, 1,000 miles is very far away, right? California is far away. The other side of the Pacific Ocean, Japan, Indonesia, Europe, they're all far away. So recording all of that at 40 samples per second is overkill. One sample per second will capture all of the data I need for the resolution for something that far away. It's no different than the mapping analogy we had before. I don't need, for erosion control, I need high resolution because I'm looking at the fine details. But if I'm just looking at the US, I pull that way back and I can use the very generalized form of that. So the resolution is the sample resolution, for example, the distance between GPS points along a road, or the size of a pixel for elevation. So I'll go, like I said, I say, well, you'll hear me say 30-meter DEM or 10-meter DEM or even 5-meter DEM, 1-meter DEM, or sub-meter DEM. Okay, that's the resolution. It's the size of the actual cell. All right, so 10 meter by 10 meter is by far the most common nowadays. However, you can get much finer resolution than that. All right, so it's just, when we talk about resolution, just understand it's the sampling interval for the data. If we're doing temporal, which we don't do in this course, but you can do in GIS, it's how frequently over time, temporal is time, how frequently over time was the data collected. Um, Dr. Shangping Su does this type of stuff using a specific type of raster data that allows you to have one snapshot, if you will, of an area over the entire course of the year. It's kind of fun data to use. Now, precision has two meanings, but it is not the same thing as accuracy. So the first one is the significant digits of a measurement. So is it going out to hundredths of a meter or thousandths of a meter? Okay. And the other one is the statistical variability of a repeated measurement. Okay. What are the confidence limits? What, is it, if I have it at the same spot, is it within 5 meters? You know, so those are the types of things you want to understand. That goes to, let's say, the type of data collection method. Am I using a real high-end GPS unit from Trimble, or am I using my phone? That's where the precision type of stuff comes in. When you're doing road work, survey precision has to be much higher resolution than, let's say, your phone. You can't have road center lines off by plus or minus 5 meters. Bad things will happen. So the idea is what is the data collection method and how well is it actually saying where that particular point is in space? Another consideration when you're dealing with GIS mapping is what's called logistical consistency. Again, we don't do a ton of this in this course, but it's an absolutely vital, essential concept to understand, especially when you go out to the real world. And let me explain this. So it's how well the data set represents real world relationships. Are the boundaries identical? So for example, if I'm mapping states, the boundaries should line up exactly. There shouldn't be gaps. There shouldn't be overlaps. They should map exactly next to each other. When you drive from Milwaukee to Illinois, there's no gap between them, although sometimes maybe we wish there was. There's no gap between the two states. It's a continuous road, and that's how it, when you cross from one polygon into another. The same thing applies to lines. If I have two streets, the vertices of those streets should match up exactly perfectly. All right. That's how we get intersections. When we drive, they're not offset. They don't stop, and somebody would get fired if that happened. Those relationships have to be maintained in GIS. The program must know that that vertices should be exactly at the midsection of the line to create this particular tease. So this is a big no-no here. You should not have any gaps in your lines or intersections. Okay. So the idea is the GIS allows you to maintain these relationships. It's one of the things that sets it apart from a regular database management system. We'll get into that more later. It allows you to create rules for these types of things, making sure everything's keeps your data integrity intact, and so you don't have gaps and overshoots and things like that. Another important facet of doing GIS is citing the data. Just like in any other science, you have to have a bibliography. You have to tell people where you got the information from. Now, the thing with GIS is there's a lot of different formats for this, depending on, you know, which type of entity you get it from, and but a lot of places will tell you how to cite the data if you use their data for whatever. It is professional and ethical to do so. I admit I don't do this very often because I don't publish things very often. So I'm working on getting better at this myself. So an example of this is, the data set name. So let's say the NCRS soils data, published in, let's say, 2010. Usually they're about every 10 years. Source type, there's a URL. Add all this stuff in there, to the what's called the metadata, uh, or on your map itself. Let's say under a credit section, to make sure that people, understand that it's not your data. You're just using it and using it for analysis. So here's a few more examples, for citation examples, and I'll just let you go ahead and read through those. Any one of them work, and you could, it's like the geosciences. You gotta just use whatever format that, is usually accepted, depending on what journal you're writing in. But the data should be cited. All right, I'm going to quickly go through this just to kind of give you an understanding of, um, the history of ArcGIS. And it, why is it important? Because it's kind of nice to understand where things have been and where they're going. And part of the reason why, normally I skip this slide, but part of the reason I'm not this time is because I decided when we had to go sort of all online, I was going to wait a year to make the switch to ArcGIS Pro. I'm still kind of learning it myself. So I figured it would be important to kind of give you an understanding of where things were and where they're going now, because I have to learn a lot of this myself. I don't, you never want to fall behind, so to speak. So back in the real old days, we had what was called ArcInfo, and it came with all of these particular programs. Now, that was all command line driven. That was, you typed everything and there was no fancy interface. It was all done on Linux, Unix machines, and which explains a lot, which we'll get to later, especially when it comes to raster analysis. Um, and you had to basically be a programmer to understand how to use it. So what they did was, with the advent of the newer Windows operating systems and the nicer, graphical user interfaces, or GUIs, they created what's called ArcView 3. And ArcView 3 was the first sort of uh, packaged system that allowed people to visually see what they're doing on a screen with a GIS, within GIS. It wasn't sort of what we're using now. It's sort of a scaled down version from what I've heard. I've never used that version. And then eventually they came out with ArcGIS. Now I don't remember all the years for this. I started doing GIS around 2003, and that was in version 8.2. So I think this version came around 2001, I want to say, if I remember correctly. Um, and they've been updating it every year since. Now, this is the version up until this semester we've been using. The current version is 10.8. It's the version I know the best, but I will tell you this, I am not afraid of change. I think now the more I've used Arc Pro, I think you're gonna enjoy it. And from what I've heard from people that use it quite a bit now, it's way better, easier, and stable. That's a huge part of it too. It's stable. So everything that's in ArcGIS has been technically ported over to Arc Pro, plus or minus a few things. The newest version of Arc Pro now Arc Pro started, I think, 5 years ago, 3, 4, 5 years ago, something like that. Um, Not all of the capabilities from the previous version are in Arc Pro, but almost all of them are now up there. We're using the newest version, which is Arc Pro 2.5. Now, with Arc Pro, they made a vast jump, not only in the interface, it looks completely different than what I've been teaching since 2003. It looks completely different. It has sort of the ribbon tabs, kind of like the new version of Word and Office Suite. Um, it also is hugely tied to what's called ArcGIS Online. Um, and that's, we'll probably utilize that a little bit because being at a university, we have a site license and all of that, and we can utilize some sharing facets with that. But the way they envision GIS going forward is much more cloud-based and much more online presence than sort of me sitting in my office doing analysis. I'm still going to do that. And a lot of people do that. Not everybody can take advantage of all of the capabilities of the new sort of cloud-based map services and everything. But there are some aspects of the ArcGIS Pro. Mainly, this is one of the big ones here. This ArcGIS portal is absolutely amazing. I mean, it sold me, and it'll probably make getting your data for whatever project you decide to do infinitely easier. It's nearly drag and drop now compared to what it used to be. Now there's some things I still have to work out that I haven't figured out quite yet. But overall, I wanted to bring this up to let you know that I decided to make the jump to ArcGIS Pro because sitting at my home, I had time to learn it even more. I've taken some classes. I know all the concepts. It's just a matter of knowing where to click a little bit. Some because things are vastly different looking. But I will tell you, I am excited, and I think the change is going to be awesome. I'm gonna have to redo some of my old stuff, and I'm fine with that. It is really really cool. So GIS comes with three tiers of levels in terms of how much you want to spend, and it's not a cheap program whatsoever. Luckily at UWM, we have the full suite of what you can do with GIS, which makes my job a lot easier. But you have the basic license, the standard license, and then the advanced licenses, which obviously the more you pay for, the more tools and technology you get with it. And like I said, it can add up in a hurry. I just bring this up because luckily at UWM, we have access to all of the tools available. Whereas in some of the other places I've taught in the past, like MATC or at Alverno, they don't. They have sort of the basic package, so we can't even cover things like raster analysis because those tools aren't available at that particular license level. GIS has been evolving since the very beginning. And back in the old ArcInfo days, they were sort of relegated to the type of technology available at the time. So if you look at this list on the left, you had things like very expensive memory, very little disk space, slow internet, if any internet almost at first, mainframe computers, and a lot of training because essentially it was programming. It wasn't the graphical interface it is today. Now we have very cheap memory. I mean, there's more memory in your phone than there was in the computers that put the men on the moon. Disk storage is completely irrelevant nowadays. I mean, between terabytes worth of disk space and then cloud storage, there's just no reason to have to worry about disk space for your files at all. Fast networks, obviously, you got gigabit connections with fiber optics and things like that. You have desktop and mobile devices, and a lot less training. I mean, you could take this class and feel pretty comfortable with using GIS. Heck, I'm self-taught, so I can do it. Anybody can do it, right? So it used to be that sort of the old model is you sit at your computer with all the data on the computer, and I still do that quite a bit because I like having my own data, so to speak. But now the newer sort of model is that it provides data over the internet. And ArcGIS Pro takes full advantage of this with things like the portal. Um, But it's not just the portal. In sort of the real world, you have lots of clients. You can have people with, tablets and desktop computers and smartphones all using a sort of central web server slash GIS server all at once. So if you think about, collecting data for utilities, they might be using a tablet out in the field or even a cell phone that has to go to a web server, which then serves back to an actual server and then, go back in the opposite direction. So it needs to be flawless, fluid, and just, it has to work. And with the networks the way they are now, both the telecom networks and the, fiber optics and everything like that, this stuff works in a perfect environment essentially seamlessly. Like you don't even have to worry about it. And it really it makes it so clients only consume what's needed. You don't have to download huge data sets to get work done. You could just grab what you need and go. Web maps are another result of that. So data being stored out on the cloud on this, on a web server, and then being able to sort of peruse that on your own is a huge part of what GIS does now. Now, with the whole COVID-19 pandemic, um, ESRI, the company that makes the program, was at the forefront of sort of utilizing their technology to portray what was going on worldwide with the COVID outbreak. So that's just one example of how people consume online maps to see what's going on essentially in real time. You could do this with a number of things. If you're going to go to any federal entity to get soil data, precipitation data, DEMs, all that stuff, from the USGS or NOAA or whoever, you're going to end up at some point at some web map that's going to ask you, okay, make a square in the area that you want to download, and we'll show you what we have available, for example. So web maps are a huge part of how we get data nowadays. The one downside to that, though, is every entity is different. So, for example, in our world, in the geosciences world, I have to get data often from the USGS for DEMs. That's one type of web map. Then the precipitation data from NOAA, the National Oceanographic and Atmospheric Association. I think that's what it means. uh, those, that website's completely different, and it downloads a lot different. It gives you this massive table. And then you have, let's say, the soils data, which I use quite often because of the terroir work I do. That's another type of data set that's completely different, and it's a very different interface. It's actually very easy, but it's not even a map. Okay, it's just, hey, what county do you want? Here it is. It's in zip format. So that one's really easy, but they're not all like that, and they're all very different. You could go to the city of Milwaukee page, and it's vastly different than the city of Waukesha page. Now, there is some similarities, but not much. And it takes some getting used to. Essentially, the first time you go there, you might have to poke around a bit and figure out what you're doing. But the more you go to it, the easier it becomes. Unless if you don't do it for a really long time, then you got to start over. That happens quite often with me when I haven't downloaded data from, let's say, an earthquake website in years because I haven't needed to. All of a sudden I need to. I have to remember how to do it, and that's just part of the experience. A huge part of GIS is going out to the web and utilizing what's out there to get data, and it just takes practice. So here's the ArcGIS Pro interface, and I will tell you it's taken me a little while to get used to, and I'm still learning where certain things are because I've been using the old interface since 2003. Well, I shouldn't say that. When version 10 came out, that I've been using it for 7 iterations, 7 years. So before that, it was even different before that. So this is the third interface I've had to get used to, and they went sort of the Microsoft Tab version of GIS. And not that that's a bad thing, it just takes some getting used to. Now, I will tell you, I'm still getting used to it, but I'm finding it to be much more intuitive and user friendly in terms of some of they made the common tools readily available right there on your screen, and that makes it a lot easier, especially for new users. Um, it hasn't changed so much. So, for example, the layers are still over here on the left. The layers are all the data that's sitting on your map. Okay, so if I put volcanoes on my map and streets on my map, or a DEM on my map, that's where they show up, is in the layer. And this is called the table of contents. You'll see the word contents here. Now over here is the built-in catalog. The catalog is sort of the file directory structure of where everything is, and you can drag and drop right from all of that. Now they've changed how this works, and admittedly I'm still getting used to it. Um, but we'll get to that a little bit later. You have things like the ribbons. Now this is new. These are ribbons up here as opposed to drop down menus. So when you click on one of those, it clicks on a ribbon. So it's sort of like a drill down menu still. However, it's not the same in terms of they're grouped sort of logically. There are still some drop down menus. And then you have within a tab, you have what's called a group. So for example, this is the navigate group. This is the layer group. You can see this here. Sorry about, and the selection group. So these are the types of interface things I'm still getting the hang of, but they seem to work really well and flow very well. And that's something that I really enjoy. And again, I'm not one of those people that is against change. This program, the reason they went to ArcGIS Pro and made a big leap and redesign is ArcGIS Pro is a true 64-bit multi-threaded version of the program. So it can utilize 64-bit multi-cores to vastly improve performance. I mean, there's literally very little lag time. There were always some issues in ArcGIS, the previous versions, because it was still running on 32-bit. It couldn't take advantage of having multiple processors and things like that. ArcGIS Pro can and does do that, which makes everything much more stable and runs much quicker. Now, well, not the downside, but one of the caveats to that is you'll notice sometimes it takes a while to refresh things. A lot of the data that you're going to deal with in ArcGIS Pro is being pulled off the web. So you're at the mercy of your network connection at that point. It's not the program necessarily, it's your network connection. So at UWM, we have a really good, we have a gigabit connection. So things update fairly quickly. I'm at home on my wireless system, and while it does update, it can take a while. I've noticed that in some of the classes I've taken. So it's a really nice layout. It's something I'm still getting used to, and I think it'll be much easier to understand once you get going. So within each one of the panes, you have various other options. Okay, you have an options menu, the three bars. This should look familiar from your phone. I mean, that's sort of the new, there's a term for those things and I can never remember what it is. Um, you can dock these, you can move them around your screen. Um, so you can see there's little drop down menus there's panels, there's icons in here, or each one of these. So this is one. If I click on this one here, it gives me everything down here. If I clicked on, let's say, this little wrench, everything down at the bottom is going to change to the dialog box that matches that particular icon. So again, it's just a matter of navigation. Takes a little bit of getting used to, but it is really easy. And as you get the hang of it, it's much more intuitive. So the contents pane is where, like I said, you could visualize what's on your map. So if I add data to my map, those are my layers, and they're put into my content panel. Now there's a bunch of different ways to view that panel. And some of these I admit I don't use very often. And a couple of these are brand new that they never used to have. So list by drawing order here, the first one is the default. So GIS, just like, let's say, a lot of vector graphics programs, they draw from the bottom up. So the layer that's at the bottom gets drawn, and then the one above that gets drawn on top of it. It's sort of like onion skinning, if you've ever heard that term before. So typically you put your polygons on the bottom, then your lines in the middle, and your points on top. That way your polygons aren't drawing over the top of anything else. Now you can drag those into various other positions, but typically you want to leave your polygons at the bottom, excuse me, so they draw first. You can also list by source. What this does is this tells you where on your disk or where out is the data being stored. Now I have multiple hard drives and I keep data in multiple areas, and sometimes you want to snag a piece of data from an old project that's sitting out on my network drive to play around with something that's on one of my external drives that I do for research. So it helps keep track of where the data is actually sitting out in space, so to speak. List by selection, we'll get more into that later. When you select features, you can, there's certain rules that have to be about when you want to select something, then the program tells you what's selected and you can then look and just see what's only selected. It kind of like masks out everything else. And then some of these other ones down here are all new and I'm still learning them myself. List by editing. So that I would assume is telling you that when you list them, uh, as if you're in an editing session, so you have to start an editing session to make changes to, let's say, points, lines, or polygons. It tells you which ones are being edited. List by snapping is going to be when you're snapping objects, that's where that logical consistency I mentioned before is to make sure that the vertices meet exactly, let's say, at an intersection, things like that. List by labeling. Labeling is a huge part of making maps. So you want to be able to list by labeling in terms of what's being labeled on top of others to avoid conflict. And then finally, list by chart. That's a brand new one. I have only played with a little bit, and I'll probably elaborate more on that later in the course. So, like I mentioned before, one of the newest things that it takes some getting used to with the new interface are the ribbons. Okay, and now you have these the tabs across the top here. So insert, analysis, view imagery, share. Okay, so those are all there, and that's where you get the tabs from. And then once you click on the core tab, so you can see the core ribbon, you'll get the different groups. So right now we're in the map tab. You can see that here. Here's the map tab, which is sort of one of the default tabs that you'll go to quite often. So you have the clipboard. These are the groups: the clipboard group, the navigate group, the layer group, and the selection group. Then you have group options, which is this little thing down here. Okay. So if you don't see what you're looking for, sometimes it's going to be kind of, I hate to say this, but sort of buried in there. Um, you also have drop down buttons. So if you want to add a base map, there's different base maps to choose from. So this is where you would go to choose the base map that you're looking for. And then you also have buttons. So these are just like this select by attributes here is just a button. That's one specific button that you click on to select by attributes. And the last one is the contextual ribbon. So within each group, so for example, in the selection group, you have three options. You have the appearance, the labeling, and the data. Okay. So now you have sort of a pane within a pane. So think of that kind of like a drop down menu, but there's more options. So right now it's on the appearance. It might be on the appearance one uh, ribbon, and then you can click on labeling if you want to go into the labeling of that particular feature or to actually play around with the data. And there's different options for each one. This is where it takes a little bit of getting used to. And one of the things that's kind of odd about this setup is trying to write it. And you'll notice that the author of the book, Mary Beth Price, has a way of doing this utilizing colons. So you'll see, like, if we're on the map tab, it'll be map colon layer colon add data. So for example, So that tells you kind of sort of the breadcrumbs of where to click, and then click, so to speak. And I'm going to utilize that same methodology, that same technique in the write-ups for a couple of the exercises we'll do at the end of the semester. But by then, hopefully you'll understand where some of this stuff is. The geoprocessing pane is another huge part of GIS. So the geoprocessing tools are basically the brains of GIS. Now, which tools you have available go back to the license level you have available. And because we're at UWM, we can use everything. We have no restrictions as to what tools we use. There are a lot of tools in this tool set, okay, or in the toolbox. There's a ton of them. And I'm used to digging through all of these toolboxes because I had to learn how to use where they were. I had to learn where they were before there was a search option. Now you can use the search option here to type in, let's say, clip in the clip tool or project or something like that. You don't have to necessarily know where they are within the toolbox themselves. And that's great. There's nothing wrong with that. I just happen to know where a lot of them are, but there's a lot of new tools in ArcGIS Pro as well. There's so much more to learn that I mean I'm right there with you. I know the basics, but there's a lot of really amazing utilities that they added to ArcGIS Pro. So this is how you're going to run most of the tools. They kind of changed how you approach analysis. Now, there are some of these tools available via buttons in the ribbons, um, but the bulk majority of those are sort of the common ones. But the bulk majority of the tools are in the toolboxes themselves. So to run a tool, once you figure out, you search for it, you click on it, and it'll open up a tab in your contents page. I'm sorry, your catalog side of your program, and it tells you what to do. So if you just want to go back, if you're just looking at something, it'll tell you to go back. This is the name of the tool right here. Here's the tool options, okay? And you can see here's the help. Now, I say this every single time I teach this class. The GIS help is absolutely amazing. If you remember way back when, and many of you may or may not remember this, there was this silly little paperclip guy that would show up on your screen in old versions of like Word or Word Perfect or whatever it was. I think they called him Clippy. Nobody used that thing. It was ridiculous. But this is different. The GIS help is amazing. Without it, I couldn't be sitting here teaching you now. That's the honest to God truth. If you have any questions whatsoever, the help is amazing. And if you don't have the program in front of you, all of the help is online as well. If you type in, this is the buffer tool. You type in buffer and the word GIS, and the first thing that's going to come up is the actual help page from ArcGIS, whatever version you're looking for. You might want to type in ArcGIS Pro, but it's all online as well. It's amazing. Use it. I mean, it explains not only how the tool is run, but when you start getting to more advanced tools, it explains to you the theory about how it works, not just, so a lot of the Kriging methods and the geostatistical stuff that I've done in the past, I've had to do a lot of reading, so I'm not just clicking buttons. I want to understand what it's doing so I understand what the output means. All right, so getting back to this, you have the help, you have the environments tab, which we'll get into a little bit more later. Um, that's basically setting preferences as to how the tool is run, like where by default is the output going to go, where to, and there's some other, those are preferences essentially. And then you have inputs. Now, you'll notice that some of these have inputs, and they are required. So here's your input. This is the one, this is the data that you're actually going to use to run, in this case, the buffer. Here's what you're going to call the output. Okay, make sure you know where you're saving your output. That's going to be huge throughout the semester. And then your linear unit, we're going to make it a 300-meter buffer. And then there's some other things in here that you can change. A lot of times you'll notice there's a lot of options in some of these tools, and probably about 98% of the time you don't have to touch any of them. They're there for very specific reasons, and it's just not worth messing around with them if you don't know what they mean. Now, if you see this little X here, that's telling you, yeah, there's something seriously wrong. That's an error, and it won't actually run with that particular X there, whatever that is. Okay. This here, this little, let me erase this. This particular little here is a warning. Okay. That's telling you, usually what that means is that you're trying to overwrite a file that already exists. That's most of the time what that means. Um, when you start doing GIS a lot, you'll find that the first time you run something is never going to be the first time, the right way, right? Usually it's an iterative process and you have to go through it several times to kind of figure out what you need and how to get it right. So, but being able to do that you don't want to generate a new file every single time that you run a tool. So what you would do is you would set it so you can overwrite the old stuff. Now, you would think, well, I don't know if I want to do that, but yes, you really actually do in this case, because you want to make sure that you're just not generating zillions of files. And then finally, and this takes me a little bit of getting used to, because in the older versions, when you would run a tool, it was a separate box that popped up. You'd fill it out and hit enter to run it. Now you actually have to click the run button, which is down here in the lower right. So just remember to click the run button. I'm just still getting used to that a little bit. But this is it in a nutshell. This is a huge part of doing GIS, is running these tools. It's the brains of GIS. So you also have something called summary statistics. Okay, so sometimes what you want to do is you just want some statistics on a particular data set. And GIS is really nice for being able to create very sort of, for lack of a better term, off the cuff statistical analysis. It's nothing super serious. You know what a sum is. You know what, let's say, the max, mean, median, all that is. And you could do that very quickly in GIS, because a lot of times that's literally all you want. And the summary statistics tool allows you to do that. And this is a bit of a new feature. Again, you could do it in the old versions, but you had to do them separately. Now you can do them, a whole bunch of them at one time, which is really, really nice. And it creates a new table as the output. So you have all of those statistics in one happy little place that you can then join back up, which we'll talk about later. But this is a nice added feature to be able to quickly do all of the statistics at once if you need them, or just the ones you need. You don't necessarily need to do all of them. Another thing that you're going to do quite a bit is select layer by attributes. You're going to do a ton of selection methods in GIS. Why? Typically, when you download a data set, you're going to get back way, way more than you actually need. If I'm doing a suitability analysis for a specific vineyard in, let's say, Dane County, I don't need all of Wisconsin. I just need Dane County. Or I might even just need a part of Dane County. So what you start to do is you start to grab just the parts you need, and that's called a select by attribute, or there's also select by location. We'll get to that in a bit, but select by attribute is one of the most basic ways of whittling down your data in GIS. If I have, you can see in the picture on the right, if I have all 50 states and I only need the three in the upper, the Northwest, then why would I want to carry around all those other ones? I can grab those, and then what I can do is say, okay, it'll ask, what do you want to do with it? And you have options, and then you can either save them or maybe just run statistics on them if that's all you care about. Um, I typically like to export my data to take it from all 50 states down to those three, and then just sort of discard, not delete, but just like put away the original data set. So I'm only carrying around what I need. So select by attribute is a massive thing that you're going to do constantly in ArcGIS. So by default, when you start a new ArcGIS Pro project, which is much different than the old versions before you just sort of created a blank map, by default, you get a default base map. And that default base map is literally the entire world. So if you click the full extent button, which typically would take you, help you zoom back to the full extent of what your data is, now with ArcGIS Pro, that takes you back to look at the entire world. So if I'm zoomed into Milwaukee County with my base map and I click full extent, it's going to zoom in as if I see the entire world. And that can be kind of a pain in the butt. That is one of the things that they added, that by default you get a base map. So what you can do is set up a custom full map extent. So if let's say I'm working on Milwaukee County, I can set it such that Milwaukee, the map, when I click that full extent button, will only go back to the extent of Milwaukee County. You can also use it to clip other layers. I prefer not to do it that way. That's a visual thing. I will teach you how to use the actual clip tool, which is probably it's a better way of doing it. But if you're making a quick and dirty map, the clip layers to extent button is a visual thing that will actually cut off everything outside the boundary that you set. So let's imagine my boundary is Milwaukee County, but I have data that extends outside the limits of Milwaukee County, whether it be train tracks or rivers, things that just don't stop at political boundaries, roads. So I can clip all those layers visually to the extent of Milwaukee County, sort of the polygon of Milwaukee County. However, I'm not actually clipping the data. I'm just sort of masking it out visually. It's a visual technique. Whereas in my course, I want you to actually, and for your final projects, that's not allowed. You have to actually clip your data down to what's called the area of interest. So if my area of interest is Milwaukee County, everything has to be clipped down to Milwaukee County. I just wanted to say that now. It may not make a whole lot of sense until we get to it a little bit later this semester, but just know that the clip layers to extent is not an acceptable way to do your final project. It's a nice way visually to quickly isolate the area you're interested in, but for your final project, that is not allowed. You can also set scale ranges. Again, if you have multiple maps, some might be zoomed in. You got your down here. You have your inset map to show you where the actual data sits. You know, this is Mount St. Helens or Crater Lake. Sorry, Crater Lake. I can read. Um, Here's the geology kind of, as an inset, and then sort of a base map of the area. So you can actually show the various you can if the user zoomed in far enough, you could have them show the geology. If they zoom out far enough, the geology will go away and it'll just show the topography. So you have the options, kind of like Google Earth, whereas as you zoom in, more and more things show up. Okay, because if you try to show everything at once, it gets very muddled, or you have to choose which one is on top, which layers are on top. So visually, you can turn things on and off at various zoom levels, scale ranges. I mentioned it before and I'll mention it again. The help with ArcGIS in ArcGIS Pro is amazing. It's just absolutely amazing. If you have any questions and I'm not around or whatever, use it. Use it is amazing. What you can find. Uh, so they've reorganized it a little bit, but I mean it's pretty self-explanatory. You could just search for, let's say, a tool or a technique, and something will pop up. You can click on it. The clip tool, the project tool. If you want to get into some more, time-space cubes, yes, that's a thing. They're actually pretty cool. But there's a lot to learn, and if you get stuck on something, by all means, try the help because it really is good. So in ArcGIS Pro, the catalog pane has been vastly updated. So this used to be Arc Catalog. Well, Arc Catalog no longer exists. In previous versions, you had ArcMap and ArcCatalog way back, like in 8.2 through 9 point whatever. And then in version 10, they incorporated the ArcCatalog pane into ArcGIS, which was a godsend. That was awesome. One of the best things they ever did. So you didn't have to open two applications. And now they've taken it even further and subdivided the pane into various um, uh, so you could find all kinds of data wherever you need it. So for example, for your project, that's where your data is going to be in local sources. So you're like whatever databases you have available and folders and things like that. Then you have the portal tab for online resources. And again, that's one of the huge selling points of ArcGIS Pro. They added so much data that's readily at your fingertips. It's crazy. So you have favorites, which are, I have a lot of different folders from various projects that I've worked on either from my research stuff or with other faculty members or students. So I keep things separate and try to keep organized so you could create like sort of bookmarks to get to them quickly. Those are really helpful. And then notifications, like if you want to receive to show you if there's updates and things like that, which you really can't do in our settings. That's all handled by the college. But that if you have this on your own computer, that's where you would see some of that stuff. So for the most part, you're going to use the project tool or the project tab, excuse me, and maybe the portal. But it's laid out a bit differently than it used to be. So they have things organized by maps, toolboxes, and databases and folders. That all used to be just directory structure straight out. So it's taken me a little bit of getting used to for this, but it actually is really nice as to how it works. So like I mentioned before, the portal was one of the first things that I saw that really sold me on, getting excited about using um, ArcGIS Pro. And think of this sort of like, I'm not an Apple guy, but like the Apple Store or the Android store, the Play Store, Google's Play Store. People out there that create data sets and then they turn them into ESRI, just like they would Apple or Android, the Android people, and then they check them and then vet them for like consistency and all of these things. And if the data set passes those tests, they're allowed to put them in the portal, and then they're shareable. So you can literally type in all kinds of things and find data sets that people have created and literally just drag them onto your map for the most part. Not always. Not always. You know. Now there are four main types of services. There's web maps, there's feature layers, imagery layers, and map images. And we'll get more into those as we go on, but feature layers are the best because those are the ones you can just drag on your map and actually use along with imagery layers. Map images are just sort of base map images. So there's a lot of functionality here, and especially for new users like yourselves, for your final projects, this may save a lot of time. Now I haven't done it quite yet. I've played around with it. There were some data sets in there I've been trying to get my hands on for years, um, and it just drag and drop. It was so nice. So again, just like the previous versions of ArcGIS, ArcGIS Pro is very customizable in terms of where you place things within your working area. Now, I personally am very particular about this type of stuff. I'm very used to where things were in my old version, so I got to get used to some of the new stuff. But typically, what you'll always do is leave your contents on your left and the catalog on the right. There really is no reason to change that whatsoever. I think if you try to mess around with that, you're going to get yourself confused. However, you can um, adjust certain things. You can make them adjacent to each other. You can stack things and you can float things. Like I can pull these off and make it a separate box that's sitting on my screen. Now, that's probably only useful if you have enough screen real estate to do it. Otherwise, there's really no reason to do that anymore. There's plenty of tabs and drop-down menus and they've done a really good job of putting pretty much everything where you need it. So I wouldn't suggest, especially at the beginning, messing around with those. I know even I haven't. I have not messed around with where things are on the screen. I'm just getting used to where it is by default. And if things change over time and I want to move something to a place where I feel it's more useful, maybe I'll do that. But for now, I'm leaving everything the way it was. So your data is the layers on your map. And that's one of those jargon things when we say layer, that's what we mean. If I want volcanoes, I drag volcanoes onto my map. My volcanoes is now a layer within my map. All right, so you can see here's volcanoes and volcano names. Here's volcanoes, capitals. Those are all layers within my map. Now, one of the things that kind of trips up new users is layers are stored as properties and settings for display. So the data is not actually on your map. It's being linked to your map. Okay, so your data is sitting somewhere on a hard drive and it's being accessed via the map, although the data hasn't moved. So if I remove volcanoes from my map, I am not deleting the data. I'm just taking that data off my map. And I know a lot of people in the beginning are like, something might happen, their map they forgot to save their map. That's not a big deal because the data is still there. You might have to recreate some of the pretty symbols, but the data is not missing. The data only goes missing if you actually delete the data. Please don't do that. So just make sure that you understand removing something from your map is not deleting it. That's a big trip up for people first learning GIS. So each layer and symbols can be customized to appear and behave. So that's one of the things, again, you get to put on your cartographer hat to make your map look pretty. So you can change the symbol sizes, the symbol colors, the coloring scheme, depending on what you want dark, this orange color. You can use, depends on what phenomena you're trying to map. Certain colors work better for other certain things. If you're dealing with precipitation, you'll probably want to use blues, right? If you're dealing with vegetation, maybe greens. That's sort of a common sense thing. We'll get into that later in the semester. But just know that you have full control over what each type of layer, how it's symbolized in terms of colors, thicknesses, hues, all of that. So sometimes you want to take layers that might all have something to do with each other and group them together. For example, you have these three layers here that all have to do with crater lake geology, so you can group them together. And what you can do with that is make it a lot easier to turn them all on and off together, so that's what this checkbox is. Or you can do it separately. You can also save this as what's called a layer file to quickly transfer display settings to new layers. So that's sort of like saving the color scheme, saving the symbology and all of that. We'll get more into that later on. You could set the symbols, the properties for symbols. You have complete control over everything. And they've added a ton of new stuff that you can do to the symbols themselves in terms of, it's pretty nuts. But you have color, the size of the font, um, all kinds of stuff. You want to add a halo, and halos are very common in map making, and it used to be buried in some weird dialog box in the old version. So now you have it right here at your fingertips if you want to add them. You can change properties quickly. This is the properties dialog box. You also have the gallery, which shows you all the different kinds of say polygons or lines, sort of the quick version of it, or you could personalize it in the properties. So that's it for chapter 1. I hope that these lecture notes helped you. And going forward in the class, I'm going to be recording yet more of these for each chapter we're going to do. I'm going to rely heavily on the book this semester. I'm doing things a little bit different because it'll allow me to learn ArcGIS Pro even better as I teach it to you. So things are going to be a little bit different this semester, other than the obvious of me recording these. Um, I'm taking full advantage of every chapter in the book and dropping a few things that I would normally teach this semester. You're not missing out on a ton. It's just that I really want to get dive into ArcGIS Pro, and I think you'll leave knowing the program even better because of it. So stay tuned for chapter 2. Take care.